No.
There we go, live time. What's up, Chunners? How's everyone doing today?
Has it?
Awesome to have you all over here. See, we got a change of scenery for denim. Got the skate ramp, peacock,
No,
Oh,
he's
it's
doing his
solid.
thing.
and a lovely table.
He's facing the wrong
Yeah.
way. Come on.
Maybe do a call.
Yeah. No.
Anyways, I think today will be quite cool. It'll actually be quite topical because I think, as you all know, gas prices are literally so ridiculous at the moment. A lot of people are talking about scalability and how do we. Then I'm remembering to mute after you whistled. A lot of people have been talking about scalability. You know, how do we make computation on chains? There we go. More viable, etc. And I did a bit of unsupervised learning. So it's sort of a cluster or a type of machine learning, which I'll talk about on the EOS voting data set. And I'll talk about what EOS does different to Ethereum. And essentially, I think that will be a pretty cool start. So what I'm going to actually talk about first is the slight difference just in general, how EOS works compared to how Ethereum works. So I'll share my screen quick. Let me allow this bad boy entire screen. And you folks must stop me if you have any questions. I think you guys all know a lot of this anyways. But basically what people sort of talk about is this tri-lemon distributed ledger technology, where there's scalability, decentralization, security, choose two of them. And I won't go into why this is the case. You can read this paper if you want to. I actually wrote this paper. But it basically talks about these and the certain trade-offs people take in this triangle. And sort of the trade-off Ethereum goes for is it's very secure and it's decentralized, but it's not so scalable, as we've seen. The fact that, there's a limited amount of computation, and that's sort of because every node in the network, for it to be decentralized, has to execute every bit of computation that happens in the network. So if you want it to be super decentralized and you have thousands of nodes, then every node in that network is repeating that same amount of work and doing all the work that's happening in the Ethereum network. And the fundamental limitation or throughput on the computation that can be done in the network is equal to the power of the weakest node in your network. And if you suddenly make the requirements super high, then you'll only have a few small nodes being able to run the network, and it will be more scalable. The nodes will be more performant, but it will be less decentralized because only a few nodes can do it. And basically, EOS make this trade-off. They've sort of more err on scalability and security, and they're arguably less decentralized because they use something called DPOS. So we'll first go back to Ethereum and proof of work. Basically, proof of work, anyone can join, and you hash a group of transactions, a nonce, which is a cryptographic one-time primitive, and you basically hash all of these things, and you try basically get a block that fits and that works. And it's very computationally intensive, and it's sort of like a computer lottery. And the better hardware you have, the more chance you have at quickly finding one of these blocks, and you get a reward for doing it. And every node in this network is sort of competing against each other to try find the correct block. They're all sort of randomly guessing and competing against each other. And essentially, let me add Jason. I think maybe he's joined here. No, he's not joined. Essentially, DPOS, which stands for Distributed Proof of Stake, essentially everyone who has EOS in the system, instead of having all of these nodes who are working against each other, they said, let's choose 21 really powerful nodes. So 21, I don't need the computer for this point. Let's choose 21 super powerful node operators, and they'll work together. And every half a second, one of them will produce a block, and they'll produce 6 blocks in a row, then it will go to the next person. And it's just this round robin algorithm where, okay, you produce 6 blocks, you produce 6 blocks, you produce 6 blocks, and they're all actually working together, and there's no actual mining. And what the system does have to do, though, is elect who these 21 people are that actually sort of make the blocks in the system. But it's so much more faster and scalable because they have these really powerful 21 decentralized computers running the network essentially. So anyone can apply to become, they call it a block producer, but you have to get voted in to become a block producer. And distributed proof of stake means if you have 10,000 EOS, you stake the 10,000 EOS, and once it's staked, you can vote for any one of those different block producers. Actually, for every EOS you stake, you get up to 30 votes. So if I stake 100 EOS, I can give 100 votes to up to 30 different block producers. 100 votes for block producer A, 100 votes for B, 100 votes for C, or you could just give it to one. So between 1 and 30, you can give them all your votes. And then the top 21 are chosen. Yeah, Dan, go for it.
So, do you know off your head how many transactions you can have on EOS per second?
Yeah,
what is
yeah.
the kind of scalability of?
So,
and I think Jason is here.
Okay, let me put Jason in. Jason, oh, there he is. Jason,
Yo,
only 5 minutes late. Okay. Yeah, so if you see this paper, Denim, I actually use something else called activity, because transactions, if you think about it, a transaction could be sending Ethereum or it could be executing complex logic on a smart contract. So basically, the transactions per second isn't like the best metric, but EOS does technically have way higher transactions per second. And in this case, we talked about activity, defined as a number of operations performed by the system in a 24-hour period. And technically, on EOS, this is way higher than Ethereum. So if you said Ethereum does 10 transactions per second, EOS has been recorded doing, 2,000 or 3,000 transactions per second. But yeah, we use this measure of activity to actually sort of define that.
And that measure of activity is kind of based on averages of different types of transactions, or is it just literally a live feed of actual real data?
Yeah. This is real. So I've referenced, if you go over here to the references, we'll be able to go to the website and you can actually have a look at this and how they defined operations and everything. You can see it's the number of operations performed by the system, and these are live values. So we can go check that out afterwards, and I'll post that link. Yeah, so basically the idea, as we said, is Ethereum uses proof of work, and obviously they're moving to different things, and EOS is using DPOS because it's so much more scalable, and obviously we can see in Ethereum the need for scalability, but I basically wanted to investigate what is the cost of the scalability, like, how decentralized is actually EOS, because we can all agree, Ethereum's pretty decentralized, and we're quite confident that, people can't hijack the network and impose their own governance decisions on us. Whereas with EOS, I'm like, well, maybe it sounds too good to be true. There's lots of activity, but is this really decentralized? So I conducted some unsupervised learning analysis, and if you check, this is the data set. I downloaded it maybe like 3 months ago.
And before you go into this, do you mind if I just ask some
questions?
Yeah,
go for it for now. Yeah, that's perfect, dude.
I just, with regards to how the voters work and the decentralization, can I, as an actor, vote for a node that is not part of the central system as long as I have money,
100%,
or as long as I have EOS?
So there's a list of...
How fast do they cycle? How fast do they cycle those nodes?
Producers. I think it's like every hour or so they retally the votes, and if there's been a change, then the top 21 will change. So we can actually go here and have a look. But yeah, anyone can propose to be a block producer, like, hey, I want to produce blocks, and if you can convince enough people to vote you into the top 21, then you produce blocks and you start earning money. You can see these are the ranks of all the block producers.
How do you convince people?
And you can see the rankings. Oh, I'm not sharing my screen. Yeah, my bad. Hold on, here we go. There's lots of sites that show you, like, here's the ranking of all the block producers, how many votes they're receiving, what daily reward they're getting. And you can see there's more than 21 block producers, but only the top 21 are actively producing blocks in that round robin. But yeah, there's like a couple hundred block producers. And you can see...
what's the main mechanism that the block producers use to gain votes? Like, do they promise you they're gonna put your stuff first?
They build stuff for the community. So like EOS Authority, you'll see they'll be one of the block producers, and they've built this nice ranking website that shows you everything. So the whole idea is like, if you vote for us, we're going to receive rewards, and we'll maintain the integrity of the network, and we'll build, you know, cool tools like this website, a block explorer for the community, and we'll fight against corruption, blah, blah, blah. So a lot of them have, like, it's almost a bit like politics, to be honest. But what we'll get to
is honestly like, sorry, you go.
Yeah, no, go for it.
I was just gonna say it is very similar to politics. It's like, this is the government, right? And they got to prove to their audience like that they're gonna do good work. I mean, it's almost like the proof of work is not a computational expensive task, but is like producing stuff that humans can vote on, which is kind of cool. So that's
you're
cool.
So right. And the governance happens every hour or so. The whole system changes, or every 21 minutes. I can't remember. So if someone technically is corrupt and cheats, they could be voted out 21 minutes later, and they'll no longer be a block producer. So it's different to like a president who, you know, if they corrupt, it takes 4 years to maybe get them out. So like that's quite cool.
Did the creators like blackjack or something? Why 21?
I don't know why they chose 21. That's a good. I guess they thought that was a good trade-off of like having, I don't know, enough people producing that it's sort of decentralized, but not having too many weak people to have to cycle between. Yeah, it's a good question.
I'm not sure for EOS if it's relevant. Maybe it's not relevant, but for various consensus algorithms, there's rules around numbers. So you want, like, I don't know, but it's like 2x minus 1, or like there's but it depends on the consensus algorithm. So I don't know about
EOS. You're
EOS
totally right, because I know in EOS there is some points where if a super majority of block producers over 21, so I don't know, I think it's 15 out of 21 sign something, then they can update the software or do X or Y or Z. So you need like a super majority to agree. So you're right, it's probably something to do with making those numbers nice.
And then, sorry, just one more rookie question. EOS similar to Ethereum, where it's a decentralized computer, so you can put code that is written in some Turing complete language onto the chain.
100%. So it uses a different language. It's actually a massive bounty for like $200,000 to get Solidity contracts working on EOS. But when I was using it about a year ago, they use WASM, so WebAssembly, WASM. You know what WASM is. That's what the contracts compile down to, and I used C++ to write the smart contract, so it's similar. It's like a decentralized computer with basically similar to Ethereum. The whole trade-off is it as decentralized? It's a lot more scalable technically, but is it as battle-tested and decentralized as Ethereum? Because it uses this different model to sort of mine the blocks and conduct governance and everything, which people think is a lot more centralized.
The thing I think people really have a problem with is like they've frozen accounts if they don't like you, or if someone hacks an exchange, they'll like freeze the account. So that sounds good, right? It's like, they doing good things, but it's also super corrupt. I think John's going to show you how corrupt it is later. But
that's my
basically like if you want or it's a personal opinion, but like if you want a global money system, it has to be permissionless and fair. So, Ethereum and Bitcoin are those examples, whereas EOS, who knows? Anyway, John.
Yeah. So, Yeah, as you said, a supermajority can basically do anything. So if 15 out of 21 block producers sign to, freeze a wallet or do X or Y or Z, that happens. So basically, the system is all well and fine if those 21 parties are maybe very decentralized, but let's just see actually how decentralized this whole system is. And like the first big issue that comes to mind when you think about it, why the system really doesn't work in my mind, and this is just something to discuss before I get onto the voting set, is remember people stake. So you stake 100,000 EOS, and then you can use that EOS to vote for block producers. That's how the whole mechanism works. Now, most people don't actually hold their own EOS. People send them to centralized exchanges like Binance, etc. So Binance, everyone sends their EOS to Binance, and Binance has 100 million EOS, and people are exchanging on the exchange. But now Binance is sitting on this massive amount of EOS, and Binance stakes all of this EOS and just votes for itself because it owns so much EOS, so it can earn a whole lot of money, even though it does nothing for the community. And it does the same to all of its other exchange friends because they're essentially the whales in the system. So that's sort of like the hypothesis, which a lot of people are saying is being happening, and I thought it's been happening. So I'm like, can I actually confirm this with data? So I'll show you again the data set. This data set, you can see it's got the voter name, it's got how much they've staked, and it's got all of the block producers they're voting for. So Aloha EOS producer, blah, blah, blah. That was actually the site we were on over here, I think, or EOS authority. And you can see it's basically ordered. So this is how much that's staked, and it goes down in descending order, and this person is staked. Cool. You can see this person has staked, what is this, 42 million or 420,000. And these are a comma separated list of all the different block producers they've voted for, essentially like that. So my whole idea was, let's use this data set to see how centralized it is. And first I did a bunch of statistics, which I'll show with you. And like the main statistics that are interesting are these two graphs, and this is the voting power distribution amongst accounts. So this is the number of voting accounts and the percentage of voting power controlled. You can see just the top 50 voting accounts. So these top 50 accounts over here have over like 60% of the entire voting power. That's 50 voting accounts, and these 50 voting accounts could be controlled by, I mean, they're controlled at most by 50 people, but they could be controlled by 20 people. And that's the majority of voting power who's deciding, who these 21 block producers are. So already like alarm bells going off. That doesn't seem so decentralized, does it? And you can see, with as soon as you get up to 200, that's like literally 80%. There's 45,000 voting accounts, but it's so negligible, almost all of the people voting. It's really like the top 1,000 who control the voting in the system. And here's another plot just showing the top 500 accounts and the voting power, and you can just see this graph, how insane it is. Yeah,
John, is that pseudo-anonymous as well? So essentially those accounts, someone could hold like 10 of the top 50 voting accounts.
100%, yeah. Check it these, super pseudo-anonymous, totally. So again, that's like another thing, right? It could be at most 50 people controlling this, but very likely there's people who've actually spread their money across accounts. Like, I don't know how it works. So those are just some
John.
Yeah.
Sean first.
When in the second column there, that's the amount of EOS that's been staked, right? Does that mean that in order to become a node, like one of the top 21 nodes that serves the network, do you yourself have to stake EOS and then also get votes? Or is that the amount of EOS that has collectively been staked by the voters?
So this person, just imagine this was a person and this was called Sean. Sean has staked 566, or let's say 56, 5 million EOS. So you have 5 million EOS in your own account. So like imagine you had 5 million Ethereum, and you've put this in a staking contract, and this now gives you 5 million votes, and you can vote for up to 30 different block producers with your 5 million votes. So this is the list of the 30 block producers or 20 block producers that this person has voted for with their 50 million staked EOS. And this is so this isn't a tally of how many votes these different block producers have received at all. This is just showing voter name, the top 200 voters, how much money they have and how much they've staked and who they've voted for. Because I want to look at the voting analysis and the voting patterns and see, is there something I can pick up in the data that's telling me there's EOS is full of shit, basically.
And another sort of question, over time, is it getting more concentrated or less concentrated? So, I mean, you basically earn by staking, right? So in theory, the people who stake get richer, and yeah, I don't know if that's been analyzed.
100%. So yeah, I just did the analysis in a snapshot of time, so I haven't looked at it over time, but in theory, you're right. Every single day, EOS Nation is getting 921 EOS as a reward. They could then stake that 921 and get an extra 921 votes every day. And that means number one acquires votes quicker than number two, and number two acquires more votes quicker than number three. So you're totally right, Jason. It's like a self-reinforcing philosophy where the higher up you are, the more you earn, and the more you earn, the more you can use that to vote for yourself, basically. Yay. Obviously, this was over snapshot. So basically what I did was, I'm going to bring up RStudio. I took this data set and did a bunch of stuff on it to basically, so supervised machine learning is basically when you have a function, you create a function, you get a whole lot of examples. So like, is this insurance claim fraudulent? And you have the details such as, the person, their age, how much is their claim for, blah, blah, blah. And you have the outcome, yes or no. And you have a whole lot of examples like that. And the supervised machine learning algorithm will look at all of those past examples and try to create a function f of x such that given new information, a new person, their age, how much they've claimed for, it will be able to predict using that function it's created whether, the person made a fraudulent claim or not, yes or no. So that's like the whole supervised machine learning aspect. Unsupervised machine learning, you can see with this data set, we don't have any outcomes saying like, yes, it's fraudulent or no, it's not. Unsupervised machine learning involves taking unstructured data where there's no outcome and basically using techniques to analyze it and try find maybe dissimilarities, common patterns, and unearth insights more around the data. So that's essentially what we're doing. And we're trying to find, like, is there corruption going on? So I'm just going to slowly run through this R code over here. So R, if you haven't used it, it's quite a fun language. I quite enjoy it. It's like pretty unneat and unstructured. It's a bit like a scrapbook for me, but I don't know, it's pretty fun. So basically, some of the first things I'm doing is just data cleaning. I don't want to analyze accounts that haven't voted. For example, block one, this is the actual people who created EOS, they're not voting because that would be unfair. So like, I'm basically eliminating all of those entries and stuff like that. And what I'm doing over here, DF vote is relevant. I'm only taking the top 200 voters for the data set. So like based on this paper I wrote, I said, the top 200 voters control 83% of the voting power. So I'm actually only going to, analyze the top 200 voters. I'm not going to analyze all 45,000 voters. That's going to drown out my data, and it's basically not worth it. The top 200 people are the people that are really interesting. Even 200 to 500, you're adding an extra 300 voters and you're only getting 7% more voting power. So I chose 200 as the threshold. Yeah, and I'm just going to keep going over here. This is just some hacky code I'm doing to basically get the data in the shape I want. It's not super well commented, but you guys really don't have to know what it does. So don't stress. Basically, I want to get into a form, and I'll show you now when I run it what the form looks like. The data will show. Sick. Okay, sick. So this is sort of what like our data looks like now that I've taken it from the CSV. I've run through all of those commands. It's a table, and these are just the first 5 rows. And what I've done is I've first generated who are all the block producers. So this is just imagine this is a column over here, and these are the 5 columns. This is the block producer, and this looks at the top 200 voters. So this is our main variable, and these are features. So it's got 200 features. Every block producer's got 200 feature, and each feature is one of the top 200 voters, and a true whether they voted for that block producer, or false if they didn't vote for that block producer. And in that way, based on all of these features and whether they're true or false, we can sort of start to cluster and look at which block producers, say Oswan, Generios, and Crypto Lines, which ones are receiving sort of the same votes as other block producers. And if me and Jason are receiving all the exact same votes, that's quite fishy, because that sort of dictates that the exact same people are voting for us, and likely one entity is controlling all of that power and voting for a number of different block producers, right? And then that conglomerate of block producers could likely collude to, give a super majority vote or something like that. So the next thing I'm doing is I'm creating something called a dissimilarity matrix. And what a dissimilarity matrix is it essentially basically allows us to check how dissimilar are these different entries in our table. Let me just do this. I think my plot's not showing here because maybe this wasn't big enough. Yeah, again, so you can still see it's executing. It's taking a little bit of time because when I stream my screen, my computer just dies out. There we go. Sick. Okay, so this is a dissimilarity matrix in the form of a heat map if you've ever seen it. R is really cool statistical packages to actually show you all of this stuff. And I'm going to zoom in. Actually, I'm just going to go now that I've produced it to the paper, which actually shows it somewhere. Here we go. I'm going to zoom in. And what you can see is it's got a heat map. Is everyone still there? I don't have my second screen this time, so say something.
Yes, we're all good.
Oh, wait.
Perfect.
Yeah. Sick. Okay, so here's this dissimilarity matrix, and remember we have all of these different block producers, and we want to see how dissimilar are the votes, or i.e. how similar they are. And all you need to know is if it's red, it means it's super similar. So if it's red, it means like these block producers are pretty much receiving identical votes from the top 200 voters. So like this is exactly what I wanted to see. This red block shows a distinct cluster of block producers. Whale X, EOS Fly to Mars, EOS this, New Dex, blah, 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 EOS Huboy Pool. These are basically, a lot of these are Chinese cryptocurrency exchanges. And you can literally see that they all receive the exact same votes, pretty much.
Question?
So, yeah, go for it.
The names on the left and on the bottom, so basically the labels of the axes or the items in the axes, they're exactly the same, right? And that's why we see the band of red going down the diagonal. Is that why?
100%, dude. Yeah, because you can see that Oracle go here corresponds to Oracle go here, and they receive it's the same thing. So it receives 100% the exact same vote. So it's completely red, and there's zero dissimilarity between it along the arc. You're 100% correct.
And that square in the middle is super interesting, right?
Yeah, this is another one where
like
it's
a group
literally,
of 5 or
yeah, exactly.
7
EOS
where they
and
vote
pool,
for themselves.
and you can see all of these, like EOS and pool, BP, dude, these are all like random cryptocurrency exchanges. It's fascinating.
Does the data
self-organize landscape quite fair?
Oh, sorry. Does the data self-organize into biggest block on the bottom left?
I actually don't know. So it uses this package called FizzDist. I can't. Oh, dude, fatal error. Our session aborted. How's that? Are you seeing this? I think my computer is literally being overloaded trying to stream stuff and run this code. But no worries, because I've got all of the results of the code in this paper, and you saw I was running it and it was working. So that's chill. But Sean, it uses that package, FizzDist, and all you have to do with that function is give it a dissimilarity matrix, and it auto-generates this plot for you. I don't know exactly what criteria it does to, like label them or put the biggest block down here or down there. But yeah, basically this indicates like that there is clustering and there are distinct groups in this data that should be sort of clustered together because they receive very similar votes. And again, this is what the data looks like after we've cleaned it. It's a list of all the block producers, and from voter 1 to voter 200, true or false, whether they were voted for. Yes, so this is the first plot where I basically argued based on this plot. It's quite clear there's some form of shadiness collusion going on. The next cool plot, so use a dissimilarity matrix, as I said, which was computed using Gower distance. In order to compute dissimilarity matrix, you want to see like how similar are things, how close together are they, and to figure that out, you have to have some metric of distance between two objects. So you have to be able to measure the distance between this observation and this observation. And how do you measure the distance between these two observations?
Can I take a guess?
Features, how?
Do you treat each row as like a vector, a binary vector, and then you take the square of the sum of the differences?
Dude, I think
sorry,
you're
the
totally
square
right.
root of the sum of the differences. I think it's that.
Yeah. So we use Gower distance. Gower distance is a distance measure that can be used to calculate distance between two entities whose attributes have a mix of categorical and numerical values. We only have categorical values, but I'm pretty sure that that's the algorithm. I'm hoping it will show it to us here. Sorry, guys, my computer's completely skeetzing. Yeah, so this DAISY function, that's literally what I used to do it. But I want to see the formula they've used for Gower distance. Okay, all I know is it's Gower distance. Sean, why don't you quickly Google Gower distance and see if that's how
sure thing
it does it. You're probably right. My computer can't do too many things at the moment. So the next thing based on this, basically before you cluster data, so in unsupervised analysis, clustering is basically figuring which of these entries should be grouped into a cluster because they are very similar. And you don't just want to cluster data if no meaningful clusters exist. So this over here is basically evidence that we can visually see meaningful clusters do exist, and we can continue with the clustering analysis. And I talked a bit about the feasibility of clustering analysis, and I performed some statistical tests basically to confirm it. And then it's basically some more statistical tests choosing what the optimal number of clusters should be. And there's many different tests. This one's using average silhouette width, and they mean different things. But I got slightly different results. Some said 2, some said 3. And these are basically cluster plots. showing sort of distinct clusters of block producers and the similarity of like votes they've received. Yeah, so these are some of the cool cluster plots you can generate in R, and the axes dimension 1 and dimension 2. Again, this is all actually getting quite theoretical, so I'm going to brush over it. But you use something called principal components analysis, and basically the idea is if you have 200 things on your features, you can't sort of plot it against voter 1 or voter 2. You have to sort of plot it against an amalgamation of your features, and PCA is a way to sort of amalgamate those features and have them lie on certain dimensions, so you can explain sort of the variability in the data. Yeah, so it's not worth going into the details of that, but if you want to look it up, PCA, it's pretty cool. And this thing is really cool. This is called a dendrogram. This is another way of visualizing clusters. And basically what it shows is wherever two things join, it shows that it's another way of basically showing dissimilarity or how similar are certain things. And if you see these 1, 2, 3, 4, 5, 6, they join all at an extremely small height, showing that these are all very, very similar, because at such a small height they join. And that exactly corresponds to these block producers in the dissimilarity matrix that all sort of receive the exact same votes. So you'll see these ones are the same ones that on the dendrogram look like this.
So
and basically, yeah.
Sorry to interrupt. These exchanges that are very close to each other, essentially we're saying this data is saying that they're colluding together and voting for each other.
Yeah, it's inconclusive. We can't prove it, but it's saying these exchanges are all receiving the exact same votes. Like, how can it be out of chance that of the top 200 voters, they receive votes only from 38 voters, and they're from the exact same 38 voters? Like, it doesn't feel like a democratic process. So we're basically speculating that a single entity controls those and at least has some type of vote agreement where, I'll vote for you if you vote for me, something like that. And they form this like strong block of voting similarity where they all vote for each other, or, something like that.
And in order to kind of to full on kind of break the network or falsify stuff, you'd have to have 51% of.
So I think it's actually a super majority. So there's 21 block producers who actively produce, and I think for anything to sort of pass, you need 15 out of 21. So I think it's more like 70% or so of block producers.
Okay.
But don't quote me on that. That's something I should Google after. But I know it's not just a vanilla 50%. It's a higher amount. And basically what you see on the dendrogram here is this other big block of red we were looking at over here. That big block of red is basically all of these block producers in this cluster, and you can see how similar they are because the join height is really small, and the smaller the join height, the more similar the votes they receive. So you can see for the rest of the block producers, they receive votes that are pretty sort of dissimilar, but here, all of these ones, Whale X, Atlic Lab, and if you go Google these block producers, you'll just see that they're pretty shady. Bitfinex, a lot of them are exchanges, they have vote agreeing agreements. And there was actually the spreadsheet leaked by, I think it was Huboy Exchange, which literally is an Excel spreadsheet showing the people they're voting for and the votes they're getting back from them. And it seems like they have massive vote exchange agreements. Like, I'm a big exchange, everyone deposits their EOS in my exchange, I'll stake it and I'll vote for myself, and I'll vote for you if you vote for me. And that way we all just earn more money as an exchange. We greedy. We all earn an extra 921 EOS a day as a reward. And yeah, we don't actually do any work, but we all just vote for each other and we own all the EOS. So like
John,
check here, EOS. Yeah.
Just to quantify that, I commented on the thing, you can put it up on the screen, but essentially 900 EOS is about 3,000 USD a day per block explorer. And so the yearly incentive to kind of make sure you are a block producer is about $1 million a year.
That'll do it, eh? $1 million will do a lot of dark things. So an exchange is like, why not make an extra $1 million a day? Everyone's got their EOS in here anyways.
Sorry, per year. Sorry, 300 a day. It's 3,000 a day, $1 million per year. Sorry, I do see. I said yeah.
No, but $1 million per year. Yeah, it's still like it's a lot of.
And so between the 21, that's 21 million. Dollars per year. That's up for grabs if you can collude and as an exchange you can just vote for yourself.
Yeah, so I mean, and this spreadsheet basically confirms they're doing it. The data sort of shows they're doing it. And I looked at like some possible modifications, but it feels like nothing can really fix I mean, I looked a bit at like quadratic voting and other ways, but that's basically the crux of it.
Is it?
And for
sorry.
Go
sorry. Is it fair to say though that there is this massive incentive to kind of make sure you are personally a block producer, but there's less of an incentive to kind of falsify the network? I mean, you'd have to get, as you said, 15 of those block producers, and then
it's unlikely that they're really looking to collude and falsify the network, but more they just want to make money. But then it's I guess unhealthy because it's like governors who just make money but they don't do anything. Like EOS Voidpool hasn't contributed anything to the community. They haven't made any block explorers. They haven't like participated in governance, but yet they still voted in the top because only a few people control the voting and they vote for themselves. So that's basically it. And for context, the whole idea of leading on to this analysis, like, okay, we've sort of proved it's corrupt using the data. I mean, you can't prove anything really, but there's a strong case based on like the visualizations that stuff is shady. And my whole idea was it feasible for universities and academic institutions to maybe come and become block producers? And basically, not really, because as much as you appeal to the community, at the end of the day, it's those top 100 people who control all the voting power. And if you're not an exchange or something, it's very difficult to, like, I think, break into the ecosystem. So, yeah, that's basically it. So basically, that's why I think EOS is, scalable, more activity, but definitely decentralization not quite there. Although, like, a lot of people will say the top 3 or top 4 mining pools in Ethereum control like 75% of the network. That's also like a bit of a cause for concern. Because that's like more than half of the hashing power of the network. And if these 3 mining pools colluded, they could essentially hijack the Ethereum network. Because basically, people pool together their hashing power so that they get a more stable income stream and don't just like win the lottery once in a blue moon, but they're all in this pool. And if someone wins, they will all win and share it between themselves. And that way they get a more predictable income stream, the miners. And there's like 3 or 4 big mining pools that coordinate all of this. Jason, maybe you have some thoughts on that. I know you're an ETH maximalist. But anyways, that's it, guys. Sorry, that was quite long.
No, I wouldn't say I'm an ETH maximalist, but I do think ETH is the leader in a lot of these things. I guess there are a lot of concerns about staking in ETH and how that can also become similar. But I guess some of the differences are that it's more decentralized to start with. It's open. Anyone can stake. There's no limit. I think the slashing conditions in Ethereum, I'm actually not an expert, are such that potentially the amount of loss that could happen with a big staking pool is much higher, because if a lot of nodes go offline at the same time, those nodes are penalized much more than if a small single, like if my node goes offline for a day, I'll lose, I'll get slashed, but not that much. But if 20% of the network goes offline at the same time, they'll lose a lot. So there's a lot more risk to staking in a centralized pool. And there's a whole bunch of other research that I mean, it is a big concern for Ethereum too. But I'm not an expert on this stuff. Marvin, you also know a lot about Ethereum.
Maybe anyone has any closing thoughts? Gooi them now.
I have another question.
Yeah.
In terms going back to EOS, you were making the kind of suggestion or assumption that it's these exchanges that get kind of they have a lot of EOS liquidity. So essentially they're using that to make the voting. But if the top, you had that list, that data set, and the top one was staking 5 million EOS or 5 million EOS.
10 million or 5 million or something. Yeah,
I think it was five. Oh, it was 5 million. I think
it was 5 million. Yeah,
5 million. That's $15 million of EOS token. So if you can, I mean, those top 200 has 80% of the voting power. So if you could take, I don't know, I'm going to spitball and say, if you could put up $50 million, put that into EOS token, distribute that across a couple of different accounts, and stake all of that, you'd be making $1 million a year on 50 million. It could be it's enough to kind of incentivize. I mean, surely you could vote yourself in with 50 million, or maybe meet more. But yeah,
I just think 50 million price exposure to EOS is probably nothing anyone wants. Yeah, that would be scary. But otherwise, you're right. You technically could. It's something where if you have enough money, you could buy the system.
Yeah.
I guess it is super speculative still. But it seems like in practice that the people who are in the top are so comfortable that they're not really giving a shit. At least that's what you made out.
Yeah, it seems like some of the exchanges are like that. I mean, you can go look through. There's lots of actually cool tools. There's Binance, where you can go and actually have a look and explore some of these things. There's also some other things, voting. Yeah, but that's I'm actually
that was super fascinating, super interesting.
Guys.
Is your paper public or hidden?
My paper's not public. You can read it if you want. I can send it.
Email John for the paper.
Yeah.
denimpreen@gmail.com. Fuck, that really is my email.
You can sell it for EOS tokens.
Yeah, exactly.
Oh, the Gauss distance was not what I thought it was. It's more like an average. Yeah, you take the sum of differences and then you divide it by like the number of sums that you took. So it's more like taking an average, the average distance between 2 points or something. It's more of that kind of a flavor.
But there are other distance measures. Here goes Denim. There's Euclidean distance, which is like the normal base distance.
That's the one that I was thinking.
Yeah, that's another one. I couldn't use Euclidean because they were categorical variables. So because they're like true or false, like Euclidean doesn't work. And then I think it's called Spearman distance. And it's Spearman distance is based on correlation as opposed to actual distance. And that also gives some other so it's like a correlation distance-based metric. And basically, you can do a lot of statistical tests when you have your data to see, like, is Euclidean distance more useful than this one? But, like, depending on what distance you use to generate that dissimilarity matrix, that obviously has big ramifications on what like all those other plots I was doing look like and as well. So it's like there's no clear answer to a lot of these things in unsupervised learning, but it's just like trying to experiment and stuff. Anyways.
It was very cool though. Thanks, dude.
Shot. You guys are legends. Long EOS. Cheers, boys.
Peace.
Enjoy your weekend, guys.
Yeah, you too.